Draw a free body diagram of a book on a table. So maybe to start out with here, let me just draw us a line. And we're going to say, let's just say that this is the top of a table. And here there is like a book sitting on this table. And I'm just going to attempt to draw sort of a book here. Okay. And so if we're asked to draw a free body diagram, part of what that really is about is trying to identify what forces are there on this object. So if I say, okay, what could those forces possibly be? So I'm going to write the word forces here. And let's think about like what forces are there? Well, we've recognized that gravity is always pulling on us. And so that's a force we can often start with. So I'm going to make a list here and say, okay, here's one of them. Gravity is one of those forces, right? In an earlier example, we recognized that like if a person is standing on a floor, the floor must be pushing up on them or they would be pulled down by gravity and would clearly accelerate. So in that sense, there must be some kind of like force pushing by the table on the book. One possible description I could say is that that represents the support that the table has on the book. It turns out in physics, we're going to associate another description of this force, another name for it. It's going to be called the normal force. And one way of thinking about that is, well, maybe there's two ways. One is a joke, is like it's normally there. If you put something on a surface, there's normally a force there. But I think the more correct way of saying why we call it the normal force is when there's a support kind of force that is exerted by one surface onto another, it tends to always be at right angles to that surface, and so normal is another way of saying right angles in geometry, excuse me. Gravity as well we could refer to in different ways, because you could say, hey, what does gravity really represent? It represents the weight of this book. In that sense, when we say, hey, something has weight, that really represents the pull of gravity. So to a physicist, weight is really is just a force, right? And clearly gravity is pulling down. So if I were to draw in this picture and say, okay, here's like the force of gravity pulling down, and then I could say, okay, there's lots of like little forces here, you know, pushing from the surface of the table onto the book, and somehow all those like support forces are going to add up to countering gravity. But how do we do this as a free body diagram? Because it turns out drawing lots of little forces and arrows tends to get a little bit messy, and some people will do that. One of the things that kind of comes up, as a free body diagram part of it is that maybe those support forces that I was kind of trying to draw in here as many, many little arrows to represent all the little points where the table is pushing up on the book. What if I could just represent those with a single force? Because really, they all would just add up to one single force. And that's what we're going to do in our free body diagrams. We're going to say, okay, there is the weight force, the gravity force pulling down, but there is also this support force pulling up. And that's going to represent the accumulation of all those interaction points between the surface and the book. And I think what I'll label over here on my whiteboard is the kind of symbols we're going to be using for this as we go on. So I'm going to customarily describe the force of gravity with an F sub G. I always like to use capital F for forces, and then I subscript them based on what force it might be. And sometimes there's some question of like, well, what is the best subscript to use? Because like for the upward pointing force, which I think reflects again that support, I could say F sub S for support, but since normal is the more typical terminology in a physics class, I'm going to call that one F sub N, and that's going to be my usual convention for doing that. So let's check out the answer here, because the answer in this slide actually kind of does maybe a better picture than I just drew. And it says, here's a book on a table, and it says, let's start an FBD. And just like I did over there, I label with FBD, and it says, next put in a point to represent the book. This is sometimes called the system point. So it's, in other words, you have to draw a point to kind of represent the object. But the cool thing about the free body diagram is you don't need to be a good artist for it. You just draw a point and that represents a book. In your sketch, maybe you drew the whole book, and even then, if it's not good, you're going to do fine in this class. This is not an art class, right? Anyway, but then we're going to start by putting in the force of gravity. I often like to start there because it's kind of a given that gravity always points down. It's a good idea to label forces in the free body diagram. So in my whiteboard, I'd labeled it F sub G. In this picture, I labeled it with a word. If you said like, hey, which one's correct? Either one is fine. Somebody else might put a capital G there because they say, hey, capital G stands for gravity, and that's the variable I'd like to use. So there is no really wrong with this. I think what I'm doing over here is pretty conventional in books for the kind of college physics level, which is what Physics 2A is basically at. Anyway, then there's that support force that represents the table supporting the book. There it is. But again, we might want to also use the label of normal, so I kind of had it switched right there. And this FBD makes it pretty clear when we said that the support force or the normal force has to balance gravity. You can see they're kind of two equal arrows pointing in opposite direction, so they're kind of like canceling each other out, and that explains why the book is able to just sit there and doesn't fall.